Christopher Monckton, who will be speaking to us next, I want to take just a few minutes with his kind permission and a little bit of privilege here to talk briefly about the DVD we produced, to give some background to it. Christopher was invited to the Cambridge Union to give a one-man show, basically, on global warming science. And when I found out he had over 300 slides, I started to panic, because I'd asked the fellows who produced the great global warming swindle film, Martin Durkin, Steve Green, those fellows, I hired them to get 3 high-definition cameras, and I thought let's go film Christopher do this and produce a video out of it. And so we were out to dinner with the Oxford Union students, and we got back a little late, and we realized we'd heard from Stephen Green that a green guy had shown up in the audience, and before we had arrived, had gotten to the microphone and exhorted everybody to leave, because this was nonsense. They didn't want to hear this stuff. And 250 Cambridge students politely told him to shut up and sit down. And so Christopher came in, and as brief as he is, he spoke for 2 hours and 15 minutes. And this was on a school night starting about 8:45. Not a single student left. They all stayed. Nobody in the back rows was making out or having conversations. They were simply glued to the presentation. The president of the union said after Christopher spoke, you have 10 minutes for a smoke break, a drink, potty break, whatever you want, and those who may be interested can come back for a Q&A. And you can imagine the hour it was on a school night, and I bet 80% of those kids came back and kept him in a Q&A that was very brilliant, and it's on the DVD, and we finally had to tell him to go home. Now, the reason I point this out is Dick Lindzen is fond of telling us that most people can't stand 15 minutes of a science discussion, and others tell us that we're all flat earthers. 250 Cambridge students do not sit for over 3.5 hours to listen to someone say the earth is flat. So with that, I'd like to introduce Christopher Monckton.
Can you give the presentation? Can you fix that? Yes, of course. Yeah. That should be it. Sorry. Oh, that's fine. Yeah, I won't need that. Distinguished professors and doctors, fellow inquirers into natural philosophy, ladies and gentlemen, after that magnificent introduction from Bob Ferguson, I just can't wait to hear what I'm going to say. Now, I'm talking about climate sensitivity, the one question that matters here. And as Margaret Thatcher, who had the misfortune of being advised by me for 4 years, which is why she looked like that at the end of it, she said, you have to get the big ones right, dear. And the big one in this subject is how much warmer will it get? And I'm most grateful to Professor Bhatt of the Indian Geological Survey for kindly communicating to me this important empirical result in paleoclimatological thermodynamics, which he summarizes with the simple phrase, global warming is pants. And there is also, of course, the possibility that we might be going in for a little cooling. I'm grateful to Dr. Willie Soon of the Harvard Center for Astrophysics for sending me that one. Now, as has been said quite rightly by Ross McKittrick and by David Douglas today, the scientific method is the correct approach to identifying what a problem is, whether or not we have one, how large it will be, and what, if anything, we can do about it. And our job here, as Ibn al-Haytham said 1,000 years ago, is to find the truth, which is difficult, and the road to it is rough. It takes hard work. Unfortunately, the politicians, on the whole, don't like this. This, believe it or not, used to share an office with me at Number 10. He is now the chief policy advisor to the Conservative Party in Britain, and now you know why it's been out of office for a generation. And his approach to this is we cannot question what the scientists say. Well, of course, Ibn al-Monckton says, oh, yes, we can. We've heard about the duty of skepticism. Skepticism is the highest of duties. And what I'd like to do is just to describe very briefly, before we get on to the more numerical part of my presentation, how the scientific method works in a formal sense. It was formalized by Karl Popper in 1934 in one of the most important papers ever written in the philosophy of science. You start out with a problem situation at the top there. You go down to a tentative theory, and note the word tentative. Your hypothesis is a proposal, it's a suggestion, it is not settled science. Then other scientists come in from all directions and attack it and try and see if they can falsify it, and that's the error elimination phase, EE there. And that creates, as you would expect from scientists, a new problem situation, which, says Karl Popper, one hopes is more interesting, at least, than the previous one. And this is an iterative algorithm. You go round and round the loop, and gradually knowledge is accumulated in the process. That is what is supposed to happen. But with the IPCC, we get a different thing. First of all, they do not clearly define the problem. And Ross McKittrick's marvelous work on, for instance, unscrambling the mess of the temperature data, showing a prodigious exaggeration of temperature increase over recent years, is a very clear case in point, and they refuse to take account of this. They fudged it in the 2007 report. Then the so-called tentative theory, well, there's nothing tentative about the way the IPCC is constructed. 2/3 of its working groups, that on mitigation, that on adaptation, are there precisely to say that we're not even going to inquire into whether there's a problem, we're going to assume that there is. So there's nothing tentative about that. And then, as far as error elimination is concerned, as we are going to see as I go through this presentation, it's extremely difficult to falsify what the IPCC says because it doesn't say it. There is no clear chain or sequence or cascade of equations which establishes, even in the most outlined fundamental sense, how they are calculating climate sensitivity. And in fact, only 4 papers, not 2,500, but 4 papers, are those which they cite in their primary calculation on climate sensitivity. So we're not talking of a huge consensus here, we're talking of 4 papers which they have chosen because they suit their book. Now, when I first began looking at this, I came across this quotation from Sir John Horton, the first chairman of Working Group 1 on the science: "Unless we announce disasters, no one will listen." Stephen Schneider did the same. We have to offer scary scenarios. And of course, there is Al Gore. Appropriate to have an over-representation of factual presentations on how dangerous it is. So imagine that you're the IPCC, and I'm asking you this question. Hands up, who thinks greenhouse gases have no effect or very little effect, and so we all need new jobs? Anyone? No. And that's really the extent of the consensus. Now, I then began looking a little bit more closely at the math. And I found, for instance, first of all, in the very first table of figures published in the Summary for Policymakers in the 2007 report, 4 decimal points relating to the Greenland and West Antarctic ice sheets had been moved one place along so as to multiply by 10 the really observed contribution of those 2 ice sheets over the last 30 years to sea level rise. I wrote a furious letter to the IPCC saying this table was not even included in the draft of the paper which the scientists signed off on, of which I have a copy. This has been inserted by the bureaucracy since. Why? Because they wanted to support Al Gore's 100-fold exaggeration of the imagined increase in sea level rise deriving from these 2 sheets. So I wrote to them and made them put this table right, and so you are listening today, you're honored to be listening today, to a Nobel laureate. Here is another fascinating error in the IPCC's calculations. This, again, I really started reaching for my spade and started digging here. They say, again, in the latest Summary for Policymakers, the CO2 radiative forcing increased by 20% during the last 10 years. And in fact, the 1995 concentration and the 2005 concentrations are there. That is an increase of 5%, but the increase in forcing, of course it's logarithmic, is less than 1%. And they say 20%. That is the scale on which blatant exaggerations are made. These survive the so-called peer review process, which is supposed to underlie the IPCC, and total rubbish of this kind is then paraded by journalists in the media saying, in the words of Private Fraser in Dad's Army, "We're all doomed." Here is the graph that started the scare. And when I looked at this was presented by James Hansen, one of the dozen scientists who are working and have financial links with politicians who are trying to foster this scare. He put this graph in front of Congress in 1998, and the blue or blue sky prediction zone is the right-hand half of that graph. And that's what got them all scared. Look how much temperature was going to go up according to James Hansen's GISS model. And here is what happened. It's completely different. It's following the very bottom run of his forecasts, where he assumes that by the year 2000 everybody has heeded his wise words and carbon dioxide has already been stabilized in the atmosphere. So on this, you can assume that carbon stabilization is unnecessary because we've already achieved what carbon stabilization would achieve. There are also, and this is the thing I find most striking reading the IPCC's documents, errors of omission so prodigious and so extraordinary and so numerous that it is unbelievable that anybody on reading those documents could say that they've actually established anything other than their own incompetence. Here, for instance, the upper of these two equations, F equals epsilon sigma times T to the power 4, that, of course, is the Stefan Boltzmann radiative transfer equation. That's how you convert radiant energy forcings into temperature. Without that equation, you don't know what the heck you're doing. And it is not mentioned once in the 2001 or 2007 reports. All the pages, all 2,500 pages of science and mathematics, that equation is not mentioned. Its importance may be gauged by the equation below it, which followed it 25 years later, which is Einstein's equation. In that case, too, you have energy on the left, and there is a term for the speed of light on the right. And in the sigma term up in the Stefan Boltzmann equation is also incorporated the speed of light. So these two equations are quite closely linked via Planck's black body equation, and yet there is no mention of the Stefan Boltzmann equation anywhere in the IPCC's reports. Now, does this mean they don't know of it or haven't used it? No, of course not. But the point is this, that because they haven't said how they've used it, we cannot falsify their calculations because they do not say how they've done them. And as it turns out, they have, in fact, abused this equation and effectively repealed it. And I shall demonstrate this as we carry on. But there are a couple of preliminary points I just wanted to cover. First is there has been, over the last 70 years, now coming to an end, what the solar physicists are all among themselves calling a solar grand maximum. Here it is. There has been, ever since the Maunder minimum, beginning in 1700, an inexorable increase, and there's the trend with the standard deviations plotted by Hathaway, one of NASA's solar physicists, one of the world's most respected solar physicists, this inexorable increase in solar activity lasting 300 years in a nearly uniform trend, apart from a dip in 1820, which was the Dalton minimum. There it is again, the 70 years, highlighted by Ilya Usoskin in a paper in 2003, another stellar solar scientist. And here is Solanki writing with Usoskin and others in 2005 that the previous period of equally high activity occurred more than 8,000 years ago. So this led me, as a layman, I'm not a scientist, to believe that perhaps that large hot object at the middle of the solar system might be what was causing the warming. It's happening at all wavelengths. It tracks the temperature. Temperature tracks solar activity. Even the cosmic ray theory. Here is Svensmark and Friis Christensen's paper replying to Lockwood and Froehlich's criticism of them for their cosmic ray theory. And you may like to know that this week, Ilya Usoskin has published a long and thoughtful paper in which he provides cautious endorsement to this theory, which is now becoming mainstream science. It gives a reason why the sun does have such good correlations. Here's Willie Soon's paper on the Arctic, showing the correlation between solar activity in the Arctic and temperature in the Arctic. And here's the correlation, or rather lack of it, between CO2 and temperature. And as you know, although correlation does not imply causation, lack of correlation does imply lack of causation. So that's quite an important graph. we know the sun can have a much larger influence than the 0.12 watts per square meter over 250 years, which is all that the IPCC has been willing to ascribe to it, because in the Central England temperature record, the oldest such record in the world, between 1700 and 1735, temperature went up by 2.2 degrees Celsius, 4 degrees Fahrenheit. That's at a rate about 12 times as fast as what we saw in the whole of the 20th century. It's an astonishing, rapid increase. Here is Hathaway's prediction of what's going to happen. We're going to have a big solar cycle to come, he thinks. He predicts a bigger one than almost anybody else in the field. But solar cycle 25 and following, that's in 10 years' time and outwards, much less solar activity. And they more or less know this because they can observe by the rate at which sunspots form and disappear on the sun that the magnetic convection currents beneath its surface are slowing down, and they're now below walking pace, very, very slow. And what is interesting is that this prediction was made in 2004, and we're only 4 years later now, and the actual track of solar activity is already more than one standard deviation below what Hathaway predicted only 4 years ago, and he's one of the best people in the field. And if you want evidence of how difficult it is to predict what's happening in climate, that's a good slide. We're seeing global warming, as we heard earlier, on various planetary bodies. Mars, here's an example, also Jupiter, also Neptune's largest moon, also even distant Pluto. And I don't think it's SUVs up in space that are causing all these problems. The conclusion of the 2004 International Astronomical Union Symposium is that it's the sun that caused today's global warming. Today's warming is therefore normal, it's not unusual, it's not untypical, and it will end soon. And here is what the IPCC says about the solar grand maximum. So the next question is, which we've already had addressed by David Douglas very splendidly just now, is it man or nature? Where's the fingerprint? He's shown that there is this hotspot predicted by the models but not found in reality. There it is predicted. You see that none of the natural forcings exhibit this extra rapid rate of warming in the tropical mid-troposphere. There it is. Here again the models you've just seen, and that is the observed reality. I'm grateful to Fred Singer for supplying this one from the Hadley Centre. There is no hotspot there. And this indicates not just a quantitative, but a qualitative misunderstanding of the way carbon dioxide interacts with radiant energy in the atmosphere at a very fundamental level in the models. And so then you've seen all these graphs, which I'll flick through very quickly. Here I decided, because, hey, I'm a layman, I don't believe either side in this debate. I don't even believe somebody as distinguished as David here. So I decided I would check for myself. And so I took 3 data sets: the surface data set at the bottom there, the satellite data set, which runs from about the surface up to, say, 5 miles up, and the radiosonde, which is 1 mile to 5, 6, 8 miles up. And so what I expected to see was whether or not this hotspot that's predicted, which is the underlying pattern there, actually really existed. And I found that it didn't. In fact, we've got a decline in temperature going on in the tropical mid-troposphere, and that actually gives you 5 separate tests for whether or not the models are right on this, and in every case those tests fail, so there is no CO2 fingerprint. Why do computer models fail? Well, they certainly do. Temperatures are not rising as they predicted, the hotspot is missing, so forth. Here are just a few of the things the models don't get right. So many people say these models are really sophisticated and they're getting so much better these days. Look at the things they are still getting wrong. And why do they get them wrong? Because in mathematics, you can prove things. There's my proof of Pythagoras' theorem. It's a proof without words, it is complete, it is rigorous, and that is settled science. But the climate isn't like that. Now, this is a paper which most climatologists haven't come across. Most mathematicians have. It's a paper by Lorentz, actually published in a climatological journal in 1963, in which he says prediction of the sufficiently distant future is impossible by any method unless the present conditions are known exactly, which they can't be. So in a chaotic object such as the climate, you cannot make predictions longer than about 2 weeks ahead. And it's no good pretending that you can. Even if you take a simple chaotic equation, such as the one now displayed, that can have an incredibly complex output, and here is just one part of that output. So no supercomputer, and this is Shunichi Akasofu, one of the most cited scientists in the world. He says no supercomputer, no matter how powerful, is able to prove definitively a simplistic hypothesis that says the greenhouse effect is responsible for warming. Antonino Zikiki, the most eminent particle physicist in the world who discovered antimatter. I met him in the spring in Rome. He says the observed phenomena may have natural causes. And in that, he's agreeing with the IPCC, who said exactly the same in 2001. Here again, we see a qualitative as well as quantitative failure of models to predict the changes in temperature over a period of years in the Arctic. And why is this happening? One of the most important results I've come across, again it's Akasofu who supplied this, is that high climate sensitivity to CO2 enhancement of the atmosphere is an input to and not an output from the models. They are tuned, he says, to assume a high climate sensitivity, so a high climate sensitivity is what they find. It's a circular argument. And the last word on modelling from the IPCC, the long-term prediction of future climate states is not possible. So now we get on to the numerical bit of this presentation. What we're looking for is dT, or delta T, the change in temperature that we are to expect, given the pretty easily foreseeable continuing slightly near exponential increase in carbon dioxide in the atmosphere. Now let's dispel one myth which is circulated by Al Gore and others, that somehow the Saint Svante Arrhenius said that it was going to be several degrees Celsius for a doubling of CO2. So he did in his 1896 paper, but 10 years later, in German, he wrote, as you can see there, that 1.6 Celsius, half of the 3.2 now forecast by the IPCC, was his prediction. Why did he change his mind? Because the Stefan Boltzmann equation, the missing equation in the IPCC's presentations of this, became available to him, and he realized that rather than doing 10,000 individual calculations on each wavelength as he'd had to do first time round, he could take the integrated equation across all wavelengths and get the answer. 1.6 is what he said then. The IPCC says 3.2, and when you calculate it in detail, it actually comes out at 3.3. Now, the important thing to notice here is that to calculate a change in temperature, you take the forcing, you multiply it by the no feedbacks climate sensitivity parameter, which I've called kappa here. You multiply that in turn by the feedback factor, and that will give you the answer. And so we take the forcing from CO2, we change very slightly the coefficient there. We bring it down from 5.35, which is Mari et al.'s coefficient, take it down to 5, because that takes into account that all forcings other than CO2 are very slightly net negative. So that gives you the figure there. Then K, the IPCC takes a value around 0.3 Kelvin per watt per square meter. Then you take the sum of all the individual feedbacks, which I've called B. Then you combine that with K, and note that the feedback factor F is dependent on K, the no feedbacks parameter, unexpectedly, because they don't tell you this in the IPCC's documents, but this is standard electronic circuitry science, and that's where this analogy is taken from. And so you then multiply dF by K by F. That gives you there 3.3 Kelvin. Now, we're now going to look at each of these very quickly, individually. First, dF. And you can see here that the coefficient Z in the CO2 forcing equation has been reduced inexorably in the last three reports, 6.4 in 1995, 5.35 in 2001, and I've taken it down to 5 to allow for these now very strongly net negative other forcings. And so that gives you a fall in dF, and yet an increase in climate sensitivity, equally inexorable, has been suggested by the IPCC's reports. I'm taking, of course, just central estimates here. There we have seen the hotspot absence. Now, Lindzen, in a paper that's just come out, it was published 3 weeks ago, says that we have really only caused 1/3 of the observed warming since 1979. And what that means is that you've actually got to divide all the IPCC's numbers by at least 3, because they are predicting that we've caused more than all the observed warming, and there is more warming dialed into the system already, as Hansen puts it. So the value of dF, I'm only going to go halfway with Dick Lindzen, because he has not yet provided a suitable quantitative basis for what he's saying. So I'm going to reduce the value of dF by just 1/3 and not 2/3. And that will give you, instead of 3.5, about 2.3 watts per square meter. Then we have K, where the values are all over the shop. Empirical values, 0.2. We see it again there. If you take out the atmosphere and add it back, 0.2. Here you see it climbs if you do the figures at the characteristic emission level, which is where Lindzen and others say it should be done. But the IPCC, way above everybody else, around 0.31 for their value of K. So there's a summary of it. But the two papers that are cited by the IPCC imply a value of 0.269. So that's the value that we're going to work on, because if you take even that value, you can see you get a rather unusual result. For every equal increment of forcing that you apply, you get progressively larger increments of temperature change if you do it the IPCC's way. That is an offense against and a repeal of the Stefan Boltzmann equation and of the laws of thermodynamics. And it's on that basis they do this. Now, if you take the model's prediction that there's going to be this hot spot, then you're predicting that temperature will rise faster on average right across the mid-troposphere than they will at the surface. And what you're implying there is that you apply any forcing equally at all points in the atmosphere. That can't be right, because you then no longer get, as you can see from these contours here, a uniform lapse rate. If you start with a uniform lapse rate in the center there, whichever way you go, it will change. So the IPCC's formula also does it this way, but that too isn't right, because as we shall see, there has been no temperature change in the, at the characteristic emission level for the last 35 years. That's that one on the right there. Change on the surface, less change a bit further up, no change at all, just there. So therefore, we come to K, which is, this is perhaps the most interesting slide of the lot, because here, an imprecision, a failure to use the standard precision of 3 decimal places, and they use only 1 in most of their calculations in the IPCC. They say K around 0.3. You'll see this in the literature all the time. People just cite this without checking it. It's actually 0.269 if you use their references. And that using of 0.3 instead of 0.269, it's only a 12% hike because of the rounding. But it leads to a 50% hike from 2 to 3 degrees Kelvin in the central estimate of climate sensitivity. That is how sensitive these calculations are to tiny distortions, and you can bet the IPCC duly puts the distortions in. And the world will laugh when it sees that. So now, here is the value of K. I'm going to take 0.269. For various technical reasons I haven't time for, that itself should be reduced by a further 10%, giving us 0.24. Then we come on to the feedback sum, and the thing you need to notice here is that this feedback sum has been increased, without saying so, by the IPCC by 51%. Over the last 12 years. There is no empirical basis for that at all. There's no theoretical basis for it. They've done it because they want to have large figures. So the value of B I'm taking back to the 1995 level. This is a diagram that simply demonstrates that F is indeed dependent as much on K as it is on B. There is a demonstration of how the feedback inflation has happened over the last 12 years without them saying so. I had to back calculate all this to generate that graph. This in turn shows that what they're doing is they're pushing all the numbers towards what might look like climatic instability and a serious runaway climate effect, which in fact there is no warrant for in the historical record, as we've just heard. So the value of F, I'm simply taking the value of B, the sum of the feedbacks back from the 1995 report. I'm taking K at the value I explained, and I'm running it through. It gives you half the IPCC's value. We conclude then with multiplying these 3 quantities as we have adjusted them together, compared with the IPCC's thing, and there you are. We've made quite small, quite sensible, entirely scientifically justifiable and verifiable adjustments to each of those 3 parameters, multiply them together, and your sensitivity comes out at less than 1 degree Kelvin for a doubling of CO2 concentration. That's about 2 Fahrenheit. So we don't have, on any view, a problem. And even that could be an exaggeration. The IPCC doesn't tell you this, but half of the incoming solar radiation is already in the infrared. Allowing for that, allowing for the fact that Professor Lindzen may indeed be right to say that we need to take it down by 2/3 the value of DF itself, taking K down to the value it's observed at the surface, assuming that Lindzen is right in saying that there are no feedbacks, you could actually calculate DT down to 0.2 degrees Kelvin for a doubling of CO2. So the 0.9 that I've calculated as a central estimate is perhaps more like an upper bound. There is no consensus on what the value should be, as that table shows. These are some of the items which the IPCC have left out in their description. That's why nobody's noticed any of this stuff before, because it isn't in the IPCC's reports. You have to go through and work it all out. And here is the proof of the pudding. Hansen's graph originally with the IPCC's 1990 projection in orange there, and the actual trend shown in magenta, and you can see that actually the real trend is half of what the IPCC had predicted in 1990. Now, I have a simple rule, same as that of Sir Geoffrey Howe, who was the finance minister of the UK under Margaret Thatcher. If I don't understand it, I won't act until I do. I cannot understand how the IPCC comes to its enormously exaggerated value of climate sensitivity. There is a strategy I think we might take now to blow this whole thing out of the water, because on the basis of these figures, I think we can. I end with a prayer. God bless America, and thank you all for listening.